YouTube's not saying live yet. Go live. Okay, so hopefully we're now live on YouTube, and with me on the call is Rich. Hi, Rich, on Community Hangout channel.
Yep, I'm on the Community Hangout channel on Discord. Anybody else
Cool.
can
So
join us
anyone
there.
who wants to anyone who wants to drop by and join the conversation on the Convex Discord, please drop by the Community Hangout channel, and we'll all be in there. Otherwise, I'll be talking through, trying to read the chat as much as I can, and talking about the very interesting topic of rethinking smart contracts. And what I hope we can do in this session is talk a bit about the big ideas behind smart contracts, and what's important about them and why they're valuable. But then let's actually get a little bit practical. Let's actually try and implement a smart contract live in the sort of convex testnet environment, and see how that works, see how we actually apply the principles that are important for smart contracts, and how it's possible to actually build smart contracts in new and quite interesting ways. And hopefully there'll be something interesting, whether you're more interested in it from the business and legal side of smart contracts, and also if you're interested from the more technical side about how actually you can make these things work, and how you can make them efficient, and how you can make them sort of facilitate the kind of open, decentralized economics systems that we want to see. And I'm sure Rich will chip in with any questions when I fail to explain something sufficiently clearly. But let me start off with just at least how I think about smart contracts. Is very much it's a contract which is self-executing. So obviously anyone can build a contract using conventional legal systems written on paper, and you can agree to a contract. But a contract is just a piece of paper. It may be legally binding. It may be possible to enforce it through courts of law, but it doesn't in itself guarantee completion of anything. Yeah, it might go completely wrong. People might not do what they agreed. Some unexpected events may happen, etc., etc. The cleverness of a smart contract is the smart contract actually executes the agreement. So whatever it was that was agreed automatically happens. And this happens hopefully independently of the actions of any party. You want it to be as close as possible to being fully automatic. So there's no ambiguity, and there's no risk of failure in important aspects of the settlement of the contract. And that could be lots of things. The contract could include a transfer of assets, it could include the transfer of a legal right, and it could include the transfer, for example, monetary compensation for a contract. You put whatever you want inside the contract agreement. You want all of this to happen, hopefully, as agreed. And in that sense, it's a bit of a challenge for traditional legal systems. So traditionally, a contract, you have to have an agreement, and you have to have a meeting of the minds. Both people have to, both have agreed on something. And there's lots of precedent and lots of legal complexity on, how you determine what was actually agreed and how you interpret the contract, etc., which we won't go into quite so much. But the point is, all of those things that have been worked out through contract law tend to have an analogous thing in smart contracts. So the idea of, for example, agreeing to a contract, well, traditionally you might have used a verbal agreement, or you might have used, maybe on a more important contract, you would use a signature, and maybe on a very important contract, you would have a notarized signature. So a way of helping to ensure the authenticity of that signature. Now, of course, in smart contracts, the way we typically do that is with a digital signature. So whenever you execute your side of the agreement, or you sign up for something, or you write your name on the contract, you're doing it with a digital signature to validate that. So everything in the legal world sort of has an analogous thing in the smart contract in the decentralized world. The key difference is that the smart contract can automatically execute and make things happen. Yeah. So if the contract is for payment, it can actually make the payment complete and settle and go through according to the terms of that contract when it's agreed. Am I making sense to you, Rich?
Yeah, you are. I just have one question. Lots of people make contracts for money transfer. And one of the things that happens in a lot of these cases is that people don't pay the money. How do you guarantee that the money gets paid? Do you have to have something in place that ensures that the money is there first?
That is a great question. So it kind of depends on the contract. So you can have contracts that say, you know, pay now, or this contract is valid upon payment. Yeah, so in the legal sense. But you can also have contracts that say, okay, you can pay in 30 days. Often payment terms are specified in contracts. And it's the same with smart contracts, yeah? You can have a smart contract that you literally cannot sign unless you pay the money. Yeah? And it will only actually let you sign if you actually pay the money at the time of signature. So part of the enforcement of the contract would be tying the signature to payment. Yeah? So in that sense, the smart contract can in fact enforce the payment. The payment has to happen in order for the smart contract to actually be signed. But you could equally write a smart contract that says, okay, you can sign it, but to settle it, you can pay up to 60 days later. Yeah. And
Is
again, that's
there
down to the terms of the contract. And a smart contract can do either. But again, you still need to make a decision when you design the contract how you want payment to work, if that makes sense.
So, um, thinking you of a real life example is have friends that are a number of freelancers, and the problem is when it's work like that and it requires revision, and it isn't like a final product necessarily. It's kind of ambiguous. But is there any way with smart contracts to fix that difficulties? Because my friends have said like sometimes they end up waiting 2 months to get paid. Um,
Yeah.
so it's very
So you could with the request, yeah, and a request could also be a revision. Yeah. So when you say first book the freelancer, for example, you can say, okay, I'm putting $100 into the smart contract, into escrow. Yeah. And so it's already gone out of the buyer's account, but it hasn't yet been paid to the seller because the buyer wants to withhold his confirmation that the job's been complete until he's actually seen the work or something like that. Yeah. And if he wants to do a revision, let's say he can do a revision, but then whenever he does a revision, he has to pay. He has to approve the previous work.
okay.
Yeah. So
No,
then
that's
seller
so
gets
an
the initial
escrow.
amount at least.
Okay, so it's more protection for the freelancer. That's,
Yeah.
that's all right.
I mean, ideally, you want to make it reciprocal to build up trust. Yeah. Because the average person, if someone says they're going to do something that you really want and you're willing to pay $10,000 to, you're not just going to give $10,000 up front if you don't trust that person. Yeah. And likewise, if you're providing, sending a valuable item in the mail, you're not going to do that unless you've seen the money or at least trust that that person's going to pay you for your masterpiece. So whichever way around it is, yeah, you've got to build up trust. So an obvious way to do that is to start with smaller amounts, yeah. So proving commitments, and then you build up trust as the relationship progresses. So that can be part payments. It can be doing a good job on the first 25% of the work, getting 25% of the payment, etc., etc. So you can structure the contracts in ways that you can build up trust as the relationship progresses, whether that's separate contracts or whether that's a single contract. And you can
I
do
think
things like escrow. Yeah, you can have the contract. So I think an important idea as we start to rethink the world of contracts is the idea that the contract itself is managed by a decentralized actor. Yeah, it's like this virtual person who is enforcing the contracts on behalf of the participants. And that virtual actor can be a participant in transactions. Yeah, they can actually hold assets on behalf of one or more of the actors and hold those assets until they need to get released or until the contract says that they should be released. So you can do more sophisticated things when you design a smart contract with the idea of this autonomous actor being a neutral enforcer and arbiter of the contract.
There's a
Yeah, a
question
great
on the
question from
YouTube.
chat, by the way.
Yeah.
So from Len, could an escrow holder release when both have agreed? Absolutely. So you can make it so it releases only when both parties have signed their agreement on completion. And could it be an oracle? Yes, it could also be an oracle. So your escrow system can have an oracle attached to it where some external party or some external data source provides the confirmation that the criteria for the release of escrow has happened, which might happen, for example, if you're using a third party that's like certifying that a certain event has happened or something like that. That could be a good use of an oracle. So yeah, great questions. Sorry, what, Riley, were you going to ask another follow-up? Sorry, I thought I heard a follow-up question on chat there.
Yeah. I have a follow-up to that. Sometimes people are paying for something with money they don't have yet,
Yep.
like their paycheck.
Yep.
There's no way to escrow their future paycheck, is there?
You're correct. So you couldn't put into escrow if you couldn't put the paycheck into escrow. What you could put is a credit note into escrow. So this is where you start to think about, okay, what is the actual thing which is being used as the currency, the underlying currency of the contract, and a contract which sells something for a credit note. Well, in fact, what are you getting? If you can put the credit note into escrow, and then when you complete the contract, you've got the credit note as the as the seller, and then that credit note presumably has some way of you being able to have some claim against the original issuer. Then you get back into credit worthiness and risk questions regarding the credit note, but at least in theory, you can make it work that way. Although probably escrow makes more sense if you're putting an actual real asset into escrow. But there's a lot of options here, yeah, and that's why I think the design of these things is super important. How you design it determines who's taking the balance of the risk, how you need to think about trust, how you need to think about governance. Yeah. So that's the some of the complexities of the space that we have to think about as we're going through. So chat, how do we code one then? Show us. Let's do it. Let's try and build a smart contract. And I am going to be live coding this. This is, to be honest, the most complicated thing I've ever tried to live code. So we may run into some technical issues or some mistakes if I do something wrong. I have tried it before, but you never know with these things if you make a slip in the implementation. But okay, let's try and implement an example of a simple actor that works for smart contracts, and we're going to implement a shop. So in a sort of seasonal festive theme, it's a cookie shop. Yeah, so you can use it to sell cookies or other baked products that you hand make and you want people to be able to give as presents at Christmas time and enjoy with their families. So that's the theme. Someone's implementing a shop actor which enables contracts for sale of some kind of baked festive products. Now, How do we do this? Well, what I'm going to do is I'm going to switch over to the convex, some of the convex tooling that we have, and this is a chance to actually show off some of these tools as well. So let me just switch over to this. There's a lot of going on here, so let's explain what it is. So this is the convex graphical user interface, and it's got the peer manager. So this is what you can run on a desktop. It's not like a web or mobile app. This is for power users who want to run close to the metal and really see what's going on. And I'm running a little test network here, and I think it's got 5 peers. These are the 5 peers that are running the test network. And if I'm to run any transactions, I see all of these numbers change. It's a way of just monitoring the network and seeing what's going on in the background, make sure it's all running smoothly. Now, these windows I have here, these are REPLs. So the REPLs, if you joined or saw the video from last time, we talked about how in Convex you can issue live commands to the network and see the immediate results. So if I'm going to enter a command in here, like add the numbers 2, 3, and 4, and enter that, I execute it and I get the result. In this case, the result is 9. So it's exactly like the sandbox REPL on the web, except I'm just running it locally on my desktop. So all of the power of Convex you can access through this interface. So I've actually got 3 windows here, 3 different REPLs, and the reason I have 3 different REPLs is actually we're going to be talking about 3 different perspectives on this in this quick demo. So perspective 1, and this is this big window I have open on the top here, is going to be the person who's building the shop. So I am actually implementing the smart contract. I want to make it all work. I want to make sure that all of the code is correct and that people can sell cookies through my shop. The window down here is going to be the seller. So this is a cookie maker who wants to sell cookies. And the window here is going to be the hungry person who wants to buy some cookies. Yeah? So you've got a buyer, a seller, and let's say a shop operator. Now, the shop operator isn't going to be an active participant, however. This is an open smart contract system. So what they're going to be doing is writing the smart contract logic that then lets everything else operate. So hopefully that's sort of clear as a setup. I've just done a little bit of pre-setup to this to make sure that we've got some assets to play with. But if we use the asset library, we can see we have an asset called cookie. And cookie, I have 100 cookies in this particular account. In this account, I have, again, some assets. I've got USD in this account. So I've got actually 3,000 US dollars. So if you imagine these as being cents, I've got 3,000 US dollars. So that could probably buy more than 100 cookies. But you know, this is the wallet of the cookie purchaser. Right, and that's the initial setup. We want this shop so that the cookie seller can list their cookies for sale, therefore making an offer of a contract, and the person who wants to buy cookies can come in and say, yes, I want to accept that offer and I want to buy cookies for that amount. So how are we going to do that? Let's take it from the perspective of the shop. So first of all, I'm going to have to define a bit of data. How much data do I need to make this shop work? Well, at the very least, I'm going to need something to store the items for sale, the listings, if you like. What are the things for sale in this shop? So I'm going to use def to define, and I'm going to define something called listings. And I'm going to define it just to be an empty map to start with. There's no listings at all in this shop. Yeah, empty shop window. Now, as well as the listings, I'm going to need to find a way to give these listings some identifiers. Yeah, whenever someone interacts with this smart contract, they're going to have to be able to say, well, what is the deal? What is the contract I'm trying to accept or offer? So we need a way to allocate IDs to these smart contracts. So if you imagine each listing as a smart contract, each of those smart contracts is going to acquire an ID. How do we allocate IDs? Well, let's just give them a counter. Let's just count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to infinity. So let's just, for a counter, let's just say that the next ID, so the next smart contract created, is going to have an ID of 1. It turns out that is all the data you need to be able to set up a shop actor, a minimal shop actor. Hopefully everything else we do is just the logic. What's the smart contract logic that we need to have in place to make this work? So when you think about a smart contract, I always find it helpful to think about the states that the smart contract goes through. Yeah. So initially, it doesn't exist at all. So we've got no smart contract. Yeah. Nothing. Something has to happen that's going to create that smart contract. And then we're going to have an actual existing smart contract, and that's going to be in a certain state. Then if something happens, that may change state. Yeah. And then finally, the smart contract may be resolved. It may be fully settled, and then maybe it's deleted. Now you can make that more complicated. You can have alternatives like, a refund state or accepted state but not yet confirmed state. You can add a complexity to these state diagrams, but really it's about saying what are the states that a smart contract can be in, and what are the actions that the different participants can take that will move it between those states. Question from chat. DeFi probably isn't there yet, but could the customer buying the smart contract trigger the shipping details? Absolutely. That's definitely a possible thing. In fact, since you've mentioned it, let's actually do that in the demo. Just remind me when we come a bit later in, we can actually put in shipping details. Advantage of live coding is you can make these changes on the fly. Yeah. So the first action we want to look at though is the action of actually listing something for sale. Yeah. So currently, by the way, I set up shop just as an identifier. So it points to account number 12, which is in fact this account here is account number 12. Yeah. So I do address in the account, which is the shop. You can see it's account number 12. I just set up an alias of shop so that when we refer to it, you don't have to remember the number 12 all the time. That's completely optional, but it just makes it a little bit easier. So I defined the listings to be an empty map. Here, if I do shop listings, I can see it's empty. But as the seller, I want to be able to list my cookie. How do I do that? How do I list cookies for sale? Let's actually define a function here. So you're going to define a function, which is defen. Now, because this is a smart contract, we have to add a special bit of metadata, which is callable. Callable means that someone can call this smart contract and interact with it as a smart contract. And this allows almost like a security check. Yeah, when someone makes the call into a callable function, it's passing control to the actor and saying, okay, now the actor's in control of the transaction. They can do their verification and see what's going on. But the action itself is going to be called by the seller. Yeah, they want to call the command to list their asset. And when they list it, they're going to say, okay, what's the thing? Bad variable name, I know. What's the thing I want to sell? And what's the price I want to sell it at? That sounds to me like the minimum you're going to need to make a shop work is you need to have an item that you're selling and you need to have a price that it's going to be selling for. So let's just put in a bit more logic here. So we're going to want to just first of all, we're going to want an ID for this new smart contract, yeah, that we're going to be listing. So we're going to do a let. Let just is a bit of logic which defines names for things. So let's call the ID of this what's the idea of this particular smart contract? Well, it's going to be the next ID, because this is the next smart contract. And who is the seller going to be? The seller of this item is going to be caller. So because this is a callable method, the seller is going to call this this function, and therefore within the scope of this smart contract, or this particular action in the smart contract, they're going to be the caller. Yeah. Now, then we're going to build a little data structure to represent the listing. So we're going to call it rec, short for record, and make it better actually. Let's call it listing. Listing is going to be better. Now the listing, what's going to be need to be in it? Well, we're going to need to list what is the thing that's for sale, what is the price, and who the seller is. Now, why do we need to put the seller in here as well? Well, when we settle the contract, when someone accepts the contract, the seller's going to have to get, going to have to provide the thing, and they're going to have to, return, receive the cash. So it's no good having a listing which just says, "There's this thing for sale for how much?" It needs to say, well, who's the person who's actually, the participant who's selling this. So we need to add that into the data. So that's the sort of the setup for the smart contract. Now let's do the actual logic. Well, what we want to do is we want to update the listings. So we're going to set, so the set command is just updating some data. We're going to set the listings, and we're going to associate in the new listing. So we're going to do a sock listings. So we're going to take the old listings. We're going to add in a new key, which is the ID, and the thing we're going to add in is this record, this new listing that we've just created. So this data structure is going to go into the listings, and that's pretty much it. That's pretty much all we need to do to list an asset. The only other thing we need to do, which I always forget, so I'm going to make sure I remember it right now, is I need to set the next ID to be one more than the current ID. Yeah, if someone's going to sell multiple items, we're going to need to keep incrementing this counter. Otherwise, they're going to overwrite the initial listing, which would be a bad idea. So this is very important. This makes sure that whenever a new listing happens, it's going to get allocated a new sequential ID. Let's see if that works. Okay, so that compiled, that executed. So we appear to have a list function now within our smart contract. So let's see if this works. So I'm going into the buyer account. So I'm going to call the shop. So I'm actually making a smart contract call. So we use the call operation here. We're calling the shop, and now we need to say what action we want to perform. Well, we just called it list. So the name of the thing. I want to list, let's say, a bag of 10 cookies. So cookie 10. And I want to list it for, let's say, $2.99. So 299 cents. Is this going to work? Let's see. Okay, that's plausible. So it's allocated an ID of 2. So did I increment the ID at the wrong time? Oh yes, that's the next ID. So it's incremented the ID. The last thing returned will be the next ID in the function. So that looks like plausibly it worked. And let's say shop listings. Okay, great. So now we have in the listings we have ID 1, so the one that we just created, and the listing has the thing that's being sold, which is 10 cookies, the amount USD, and account number 13 is the seller. Yeah. So now effectively what we've done is we've put this this as an open offer to anyone who wants to come along now in the entire world, can see this listing and can go, that looks good. I'd like to buy this cookie. But we haven't yet implemented the buy function. Yeah, you can't actually buy this listing. So let's have a quick look at how we might do that. Just clear this. So again, we're going to have to define a smart contract action. So again, it's going to be a callable function. Use a colon there because it's a keyword. And don't concentrate too much on the syntax. Yeah, the syntax is just the standard convex Lisp. It's more the ideas and the concepts that we're going through, which I think are interesting. But we're defining the action, and this is going to effectively say, okay, I want to take up this offer. I want to sort of execute this this trade. So I'm going to have a buy function. I'm going to have to say, well, what is the ID of the listing I want to buy? It's no good just saying, hey, I want to buy. You need to say which particular listing do you want to buy. So we're going to need an ID as an input, and that should be pretty much everything to actually execute this this action. So again, let's use a quick let to see what to set up some values. So the buyer in this case is going to be the caller. Yeah. So I find it very handy just to give names to the callers like this, so that with the rest of the smart contract logic, you can always see who you're talking about, and it's you're less likely to make a mistake. Obviously, you test these things if you're going to deploy them for real. This is in a development environment, but yeah, even when you're in development, it's a good idea to give things good names so you can see what's happening. So let's take the listing. The listing is okay. So we're going to have to do get. So we're going to get from the listings, and we're going to get the listing that's named by that particular ID. Yeah. So we're just going to get that ID out of the listings. So get listings. We're getting it out of the listings data structure. The only thing that I like to do on these ones is there's a very high chance that someone messes this up and they give an ID which doesn't exist. Yeah. So what I quite often do is I say, well, look, let's put an or around this. If you listing doesn't exist, then I want an error. Yeah. So I want to say listing does not exist. Yeah. So you fail early if the listing isn't actually there. It's not necessary to make the smart contract work, but it's kind of helpful because it means that your user will get feedback if they try and do something that isn't going to work. And what else do we need? Oh yes, so we're going to need to get the actual data from the record from the listing. So what we're going to define is we're going to get the thing, the price, and the seller from the listing. Yeah. So this is a trick in convex Lisp. It's called destructuring. But if I've got a data structure called listing that has a thing, a price, and a seller inside it, I can do this just to make sure that the thing, price, and seller has a price. Quick question: is that a query, or does it use juice? So every time I actually define something or interact with a smart contract and I want to change data, it has to be a transaction that uses juice. Yeah. So if I was to call the shop, if I call the shop and I list something for sale, well, I'm changing the listings data, so that needs to be a transaction that uses juice. On the other hand, doing this, reading the listings, that is a query. So that can be free. That can be absolutely juice free. So no transaction cost for executing a query that's just examining what the current listings are. Yeah. So I know I ran it as a transaction, but if I run it as a query, it will run in exactly the same way. Yeah, you'll still get exactly the same result. So yes. So if you're actually writing this in an app, if you're not actually changing the state of the smart contract or the actor or any asset, it's better to use a query because it's cheaper. Or you save a little bit of transaction costs from doing so. Marginal, but it does help. So good question. So back to the buy function. So we've got the thing, the price, and the seller. I think that's all we need now to be able to actually execute this contract. Yeah. Question: if the buyer gets an error when trying to execute the sale, who has to pay? Great question. If something fails, the default behavior in convex is for everything to get rolled back. Yeah, so the entire transaction will be undone. So no one pays. Yeah, nothing happens if there's an error. Yeah, it all just goes back to where it was before that transaction was attempted. Yeah, the juice, the buyer does pay that. The person who gets the error does pay it. Yeah, so if you execute a bunch of erroneous transactions, you pay the transaction cost for getting those errors. If you try to execute them as transactions, now what you can do is you can execute them as queries first to see if they fail or not. Yeah, so this is actually a smart strategy. If you're worried that your transaction might fail, execute it as a query first, see what happens, and if you like the result, then execute the same thing as a transaction, and hopefully nothing's changed, and hopefully it still succeeds in the same way. So that's an option. Yeah, if you're worried that there might be an error, you can test it as a query first, and that's guaranteed to be safe. Yeah, because a query can never change the state of your assets or the network. It's purely just for information only. Yeah. So good question. Again, you can protect yourself from errors by testing that the transaction is likely to go through. Okay, so let's put in the logic to make this purchase work now. So what's going to have to happen? I need to make sure that I've got that it's possible to pass the thing to the buyer and the price to the seller. Yeah. So what I need to do is I need to, at this point, I'm going to use the asset accept command, which is to say, okay, I'm going to take the asset from the seller, and I want to take the thing from the seller, and I want to accept the price, whatever asset the price of the asset is, from the buyer. And this is, remember, this is the actor, this is the smart contract actor that's actually doing this. It's taking these two assets from the two different participants. So checking that they're actually it can actually access. Yeah, if the buyer hasn't got the price and the seller hasn't got the asset, this transaction can't go through. Yeah. Now, assuming that's happened successfully, remember, if either of these fails, the entire transaction is going to fail. So at this point in the smart contract, it will have. We know that both of those things have successfully happened. At which point we can do a transfer. So we transfer the to the seller. We're going to send the price, and most importantly, transfer the buyer is going to get the thing. They're going to get their cookies at the end. Yeah. So if all of this has happened successfully, then the seller has got the selling price and the buyer has got the asset. Again, if any of this goes wrong, all of it gets rolled back, and no one's any worse or better off at the end of the transaction. The final thing I just want to add in, which is kind of optional, but it's good practice, is to delete the listing once it's expired. Yeah. So let's say these are, you could obviously you could make a smarter system that had, there's 10 bags of cookies or something. It decreases it by 1 each time you sell a bag of cookies. But in this case, let's just say that once you've made the sale, the listing disappears. And we want to do this because we want to clean up the data structure, and you actually get some memory allowance back in convex if you deallocate data from data structures. So it's a good practice and good for your users to clean up things afterwards. So we're just going to dissociate the ID from the listing, so the listing is going to disappear. The other thing that Riley, I think, on the chat mentioned was shipping. Shipping details, yeah, which can be added as a parameter. So I want to buy this particular listing, and here's my shipping details. Yeah, so you can add in extra parameters if they're important to the contract in places like that. Um, so let's just execute that, see if that is. Oops. Okay, error. Okay, so my mistake. I used a def instead of a defen. I'm defining a function. So yeah, so def requires symbol and expression, and I obviously wanted a defen because I'm defining a smart contract function here. Okay, attempt two. Okay, that looks like it's compiled successfully. So we appear to have a buy contract. Um, So, question from chat: any chance of visual programming with drag and drop? Absolutely. Everything that I'm doing here, you could do in a drag and drop GUI. So you could say, okay, here's the price, here's the things you've got to put in, here's the things that you get out, whether that's assets or whether that's some other kind of interactions. You can make different components for different kinds of smart contract interactions. Great question. I'm super excited for building one of these because I think it actually would be very, very powerful. And it would make smart contracts accessible to people who are not developers. I mean, currently smart contracts are considered rocket science. I'm trying to prove here that it's only a few lines of code. There's not actually that much code required to make these, but it should be zero. I mean, you should be able to drag and drop and have the visual interface that assembles this code, that writes the code for you, and then it's going to be even easier. I mean, it's going to be super accessible. So exactly, yeah. So I mean, this is already unique, by the way, in the sense that what we're doing is we're building this smart contract live in a running system. Yeah, we're not creating this independently and then deploying it. We're actually editing the contract rules, if you like, live because we have this on-chain compiler and this meta-programming capability in the convex system. But yes, we can even add some fantastic things on the user interface element as well, which I think is going to be extremely powerful. And of course, all of this can happen behind a GUI. Yeah, so you can have a mobile app, or you can have a web application, or you can have some enterprise system that's actually executing these commands on behalf of users. So normal users would never be seeing this sort of level of detail of how the smart contract is actually specified. But I do think it is important to at least understand that this is the sort of stuff which is going on under the hood. Ma and Pa from the donut shop will need the drag and drop. I'm hoping it's like it'll be like a little mobile app. Yeah, so what do you want to sell? Upload a picture. How much you want to sell it for, etc., etc. And then all of this just happens for them in the background. I think that's the way you'd hope that this sort of thing would be work. Or your AI assistant does it for you. So it's like, hey, I'd like to sell a bag of 10 cookies. Can you create a smart contract for me, or that will represent my listings? And I'd like to sell 10 a day, and I need 2 days to bake them and ship them, or whatever. And then the AI can go and do the drag and drop for you and build the user interface and build the and post the listings for you. That's exactly the kind of thing that we're envisioning with the sort of AI powered open economic systems that can exist on Convex. So yeah, great questions. Thanks from the chat. Okay, we've got to test this still. We've got a quarter of an hour left to get the to see if this actually works. So let's just go over to our buyer now. So again, I should be able to do shop listings, and I've got a cookie for sale. So now I've made an obvious mistake, so this is going to fail. Yeah, but let's just try it. So I'm going to call shop. I'm going to buy. I want to buy the listing number 1. So I want to buy these cookies, and because thanks Riley, we've got to have some shipping details, and it's going to go, I don't know, to good test data there. Let's see what happens. Okay, so that didn't work. Now this is, I knew this was not going to work because it's not been fully set up. Yeah, what's happening is failing. It's the accept part of this is failing. Yeah, so if you see, we're accepting the seller, the thing from the seller, and the price from the buyer. So what's happening here? Well, this is a really important bit. The smart contract is trying to take assets from both the seller and the buyer. Now, in general, you don't want smart contracts to be able to take assets from arbitrary people. Yeah, that would be an enormous security risk. If any smart contract could take any asset from any person, you could see how that could be quite easily exploited. So the one other thing that we need to do to make this work is the participants need to make the asset available to the smart contract. Yeah. So the cookie seller needs to make it possible for the shop smart contract to take cookies from them, and likewise the buyer needs to make it possible for the smart contract to take US dollars from them. So even if they both agree that this is what they want to do, they still need to authorize the smart contract to perform that action. Yeah. Otherwise, you've got this massive security risk. So let's just do that quickly. So this is I'm going to offer to the shop, and I'm going to offer, let's say 100 cookies, because I'm going to be selling multiple cookies. I'm going to offer 100 cookies for sale, and maybe this first listing is just 10, but maybe I want to sell some more later. So we can always offer more than the contract needs. Yeah. The problem is if it's less than the contract needs. And likewise here I can do asset offer. I want to offer to the shop, and I want to offer. Let's say I'm going to be quite careful. Yeah, I want to be sure that this shop is not going to take any more than $2.99. Yeah, so I want to offer the exact amount that the contract is going to require. So that's a $2.99 offer. And now, if I try and buy, I think this will work. Oh, okay. What's gone wrong? I've done something wrong. Bad asset argument. Buy 1 to my house. Asset accept. Asset accept. Okay. So I got the argument. See, error, my mistake. So I'm accepting from the buyer the price, rather than the price paying me the buyer. That wouldn't make sense. So you're live coding, so these things happen. So I've just fixed that now. So yeah, so the first argument is the participant, and the second argument needs to be the amount of the asset which is being traded. Okay, so now hopefully.
But Mike, if you were actually building this smart contract outside of Convex, wouldn't you not be able to see that until you were all done?
If you're building it outside of Convex.
Yeah, if you built it in another chain.
So if I was building this as a real contract to put live, I would do this in my own testing environment. I would go through, I'd make sure it's all correct, I'd make sure it's all all working as intended, and I've security validated everything, and I've tested everything, and only then would I then go and deploy this code. Yeah, I wouldn't do this sort of live coding approach of like building it as it goes through, because I might make a mistake and I might lose some real assets if I did something wrong, and maybe someone's watching and they're watching for exploits as I'm going through changing things. So yeah, you wouldn't want to live code with real assets. But if you're doing it in your own test environment, it's safe, and if you're then validating it and verifying it and then deploying it again, that's pretty safe. So,
but can you even do this in a different chain?
You couldn't live code it on. I mean, as far as I'm aware, Convex is the only technology which has a live coding compiler like this. Yeah, in the sense that you can actually modify the smart contract and do this live on chain. So that's pretty unique. But you could still do it in terms of the compile, deploy, list. The more traditional cycle on other networks. So yeah, it would be possible to do this on others. I mean, there's quite a few things here which are very powerful that are pretty unique to Convex. So first of all, the fact that we're live coding it. Secondly, we are showing the power of atomic transactions. Yeah, so the fact that we can just safely do all of this stuff and the entire thing rolls back if something goes wrong, that is atomic transactionality, and it's atomic transaction over global state. So anything that we do in the entire global state, so that can be multiple assets, multiple interactions with other smart contracts, either all succeeds or it all gets rolled back. Yeah, and you can't do that if you haven't got atomic transactions, and you also can't do that if you've got shards. If you don't have a global state, if the state is like segmented into different parts, then you can't do an atomic transaction over all of them at the same time. It becomes very complicated to build this kind of solution. So global state and atomic transactions are, in my view, essential if you want to really build powerful smart contracts that can really do these sort of globally powerful transactions. Then the other thing that I think is kind of unique. Notice at no point did I say that the thing and the price had to be fungible tokens. I just said there's a thing that's for sale and there's a price that has to be paid for it. So in fact, this shop, although we're using it with tokens, we're using it with cookies and US dollars, that could be NFTs and voucher coupons. It could be a concert ticket. It could be a share in a company. Yeah, we've not restricted the logic in any way to a specific type of asset. So we've actually written a very general purpose shop. So I actually lied when I said we were building a cookie shop. We're actually building an anything shop. Yeah, that could be NFTs. It could be a bundle of different assets. It could be a governance right. It could be pretty much anything you want. Yeah, anything that follows the universal asset interface. So the asset that supports transfer, offer, accept, and these sort of universal asset functions. So for those of you who joined or watched the previous one of the previous calls on universal assets, this is in a way showing off the power of the universal asset abstraction that we have in Convex. Let's see if I can get it to work now. Hopefully I can do it in 5 minutes. So I saw one more error. So the DISOC at the end was failing, and if I look carefully, I was changing the listings data structure, but I was DISOCing not from listings but from listing, which is this thing we named up here, which is of course also a bug. So let's fix that. Now does it work? Woohoo! I think it worked. So, how many cookies do I have? I have 10 cookies. That looks like it succeeded. How many USD do I have? That looks like $2.99 has gone out of my account. Let's go back to the buyer. How many cookies does he have? Oops. It's called cookie, not cookies. 90. So 10 of cookies have gone out of his inventory. And what does he have in terms of USD? He has $2.99. So the smart contract has basically executed that entire transaction end to end. Yeah, it's taken the cookies from the seller and given them to the buyer, and it's taken the USD from the buyer and given it to the seller. And if anything ever went wrong in that whole process, the entire thing would have just rolled back, and it wouldn't have happened at all. Yeah. And if I just check the cleanup has worked, if I go back to see the listings in the shop, you can see the listings are now empty. So that particular 10 cookies have gone out, have been sold. But of course, I mean, it's a generic shop. Yeah, so I can always right, I'm just going back with the old commands. It was a cool shop list. I can now list 15 cookies for $4.99. My price has gone up, and now the new listing is now up there. Yeah, and I can do that again. I can do it twice if I want to sell 2 bags of cookies. And now, if I do shop listings, there's 2 bags of cookies for sale. Yeah. So that's basically it. I think it's worked. Obviously, you could make this whole thing much more sophisticated. You could add in a scroll. You could add in a whole bunch of extra states. You could add in returns. You could have all kinds of extra complexity. But in terms of a basic shop that lets you sell any asset you want for whatever price the seller wants to set, this is basically a fully working smart contract, and I believe secure. It hasn't been security audited, obviously, but I believe everything in here is robust from a security perspective.
Mike, is there a place that you could look at the whole contract at once?
So you can look at the compiled code. So I can look at this, and I can see the compiled code in this data structure. Yeah, so it's not formatted. You'd have to run it through a formatter to see it in pretty things. But I can see that there's a list function with thing and price, and I can see that there's a there's another function somewhere, buy. There's a buy function, which is a bit more complicated, which does all of that. And then there's some other metadata related to the account. And by the way, that's my public key. That's this crypto key that I'm using as the shop owner to be able to update the actor. So yes, you can inspect it. Because it's compiled the code, you're not seeing the original source code. You're seeing the sort of the compiled to pseudocode version. That's actually stored on chain, but you can obviously decompile it and you can interpret what all of these things do. So if there's ever any doubt, you can always verify that this code is correct and that it's correctly performing whatever action it's meant to do.
Awesome.
The final thing I would add is, if you really are sure that you've got this code correct, and you are sure that this is the implementation of your shop that you want to exist for all time, I can remove my ability to change it. Yeah. So I've been editing this smart contract pretty much live. I've been live coding it for now, and the reason I can live code it is because I've been effectively executing transactions using this public key, yeah, and directly executing transactions in this account. If I really believe that I've done this correctly, and this is irreversible, and once I do this, I'm going to set key to nil. Get key. Set key. Nil. I can't execute any transactions anymore. I've locked myself out of this account. Yeah? So it's nobody. It's now an actor. I tried to send a transaction for an account that is an actor. So account 12 is now an actor. It's fully autonomous. A user cannot now ever transact on that account. I think I can still query. Can I still query? Yeah, I can still query. So I can still do read-only transactions. So I can still see, for example, my listings. But I can't execute any transactions. If I now try and, if I try and delete all my listings, nope, can't do that. I'm locked out. Yeah, I can't make any change to that account anymore. But these guys can still use it. Yeah, it's an actor. It's autonomous. I can still list more cookies for sale. Yeah, and I can still buy. Let's do buy. I want to buy listing number 3. Oops. I need to offer. So I need to offer more. $10. And I want to buy listing number 3. And now that works. Yeah. So listing number 3 has worked, and I should have. And I've got 25 cookies. Yeah. So I've removed the ability of myself as an author to ever change that smart contract ever again. But it is autonomous, and it will continue operating for as long as the network operates. Hopefully till the end of time. And everyone can still transact and can still use the smart contract from this point onwards. So we have a fully functioning shop. So I hope that's been a sort of interesting sort of little tour of some of the ideas behind smart contracts and how you can build them, and maybe some ideas about how we can make smart contract systems more powerful in the future. As always, if anyone's wants to have any discussions or ask any questions, there's people around on the Convex Discord, so feel free to drop by and discuss any of these sort of topics. Any final comments from chat? Yeah, so anyone can use that actor. Exactly. Yeah, so this actor is open. It's a public actor, but with locked down edit rights. So no one can ever change the logic from this point. But anyone can create contracts. So they can create listings, and they can purchase. So they can buy. They can execute those listings as a purchaser. So yeah, it's enough for a full two-way marketplace at this point. Okay, so we've come a bit past our hour, so hopefully that was interesting for everyone. Do drop by the Discord and say hello, and hope to see you all next time. Take care. Bye for now.